Welcome to Lesson 2-3, Subtracting Integers. The essential question is, what happens when you subtract integers? Please make sure you have these notes in front of you. To subtract an integer, add its additive inverse. Now the word additive inverse means that you are adding its opposite. So for example, under symbols, p minus q. The additive inverse of minus q is plus negative q. Using numbers 4 minus 9, if I use the additive inverse, I'm going to change the subtraction sign to an addition, and the inverse of positive 9 is negative 9. So 4 plus negative 9 equals to negative 5. This can also be shown on a number line. For example, on a number line, if I start at 4 and I want to subtract 9, I want to go to the left 9 spaces. Now if I go to the left 9 spaces, I'm going to end up at negative 5. If I look at 4 plus negative 9, I'm still starting at positive 4. I'm adding negative 9. That means I'm going still to the left 9, and I still end up as negative 5. So as you can see, minus 9 and negative 9 say the exact same thing. The next one, 7 minus negative 10. 7 minus negative 10, if I were to do this on a number line, here's 7, and that's my starting point. 7 minus means I go to the left, but negative means I go to the opposite of the left, which is the right, and then I go 10 over there. So I'm going to end up at 17. Now if I do 7 plus 10, I still end up at 17. I'm still going to the right 10, which means that 7 minus negative 10 and 7 plus 10 equal the exact same thing because I get 17 as my answer. So as you can see down here, the additive inverse, 6 minus 7 equals to negative 1. That's the same thing as 6 plus negative 7. The actions are the same. You're still going to the left 7, and you're still ending up at negative 1. Let's try some practice examples. 6 minus 15. So if you want to imagine yourself on a number line, and you're at positive 6, so this is your starting point. You want to go to the left 15 spots. Now if I go to the left, I'm going to end up with negative 9. Now if I think about it, if I change this to the additive inverse, 6 plus negative 15, I'm still starting at 6, and I'm still going to the left 15, and I'm still ending up with the same answer. So as you can see, 6 minus 15 and 6 plus negative 15 are the exact same thing. The next example, negative 7 minus 6. So I'm going to start out with a number line, and I'm going to put 0 on the right side because I know that I'll be in the negatives right now. So I'm going to start at negative 7. Negative 7 minus 8. So I'm going to go 8 spaces to the left. And if I go 8 spaces to the left, I'm going to end up at negative 15. Now let's use the additive inverse. Negative 7 plus negative 8. Now if you want to use money, you can say that if you owe $7 today, and then let's say you borrowed another $8 from them, you now owe them negative $15. Now that means I end up with the same answer as if I did not do the additive inverse. So again, additive inverse, when you see subtraction, it'll give you the same answer. Last example, 12 minus negative 6. So I have my number line here. I'm going to put 0 here. Here's 12. That's my starting point. So 12 minus, which means I go to the left, but negative means I switch it and I go to the right 6 spots. And I'm going to end up at positive 18. Now, if I do 12 plus 6, which is the additive inverse, I still end up at 18. I'm still going to the right 6 spots, and I'm still ending up at 18. So there are your answers. Flip the page. Make sure you have these notes in front of you. Let's do some practice. Find the difference using the additive inverse. So number one, we can go ahead and start by drawing a number line. And I'm starting at 8. So I'm going to put a dot at 8. 8 minus 13. Now if I'm subtracting 13, I'm going to go to the left 13 spots. And I'm going to go ahead and subtract those two, and I'm going to end up at negative 5. Now I can also make this 8 plus negative 13. So 8 plus negative 13. And that kind of tells me the same thing. I'm still starting at 8, and I'm still going to the left 13, and I'm still going to end up at negative 5. Number 2, negative 10 minus 7. So here's my number line. I'm going to put 0 here, and here's negative 10. So I'm starting at negative 10, and I want to go to the left 7 spots. Now if I go to the left 7 spots, I'm going to end up at negative 17. I can also rewrite this and put negative 10 plus negative 7. So that's kind of me saying, if I borrowed $10 from you today and then I borrowed another $7 from you, how much money do I now owe you? You're going to owe negative $17. So again, if you do it on a number line and if you do it with additive inverse, you're going to get the same answer. Go ahead and pause the tape here so that you can do number 3 through 10. Here are the answers for number 3 through 10. Feel free to pause the tape here so that you can finish your corrections. Finding distance on a number line. You can find the distance between two integers by using a number line. Example, find the distance between 3 and negative 3 on a number line. Alright, so what I can do is I can start by putting a dot at negative 3 and a dot at 3. And what I'm looking for is the distance, or how many units are in between these two integers. So I can count 1, 2, 3, 4, 5, 6. So there are 6 units in between them. Another way to do it is by thinking of 0 kind of being your middle point. And you should know that from 0 to negative 3 there's 3 units because of absolute value. And from 0 to the 3 there are also 3 units. So you can think of that as 3 plus 3 equals to 6. You can also determine the distance by finding the absolute value of the difference of the numbers. Example, find the distance between negative 4 and 5. So if I draw a number line, I have negative 4, so 1, 2, 3, 4, and it's between negative 4 and 5. 1, 2, 3, 4, 5. Okay, so what I'm going to do is I'm going to take my end point, which is going to be 5, and I'm going to subtract it by my beginning point, which is negative 4. So if I write it out as 5 minus negative 4. Now 5 minus negative 4, according to my additive inverse, I can do additive inverse. So really I have 5 plus 4, which equals to 9. Then I just take my answer, find the absolute value, which is 9 again, and there's my distance between the two integers. If you look on the number line, and you have 0 in the middle, you can see that on the left side, from negative 4 to 0, there's 4, and on the right side, from 0 to 5, that's 5, so again, you can also do 4 plus 5 equals to 9. So many different ways to do this. More practice. Find the distance between each pair of integers. Number 1, negative 30 and negative 22. So I'm going to start by finding the distance by using a number line. So here's my number line. I have 0. And I want to find the distance between negative 22, which is over here, and negative 30. So I want to find out how many units are in between these two. Now the best way to do it would be to take 30 and subtract it by 22. And I'm going to go ahead and get 8 units. So I know that there are 8 units in between the both of them. So I can write 8. The second way to do it is the way that I just showed you, which is to find the difference between the two. So if you take the end point, which is negative 22, and you subtract it by the beginning point, which is negative 30, you're going to go ahead and add the inverse, and you're going to get positive 8. Then you're going to find the absolute value of that, and it's still going to be 8. So either way, your answer is going to be 8. Number 2. Negative 6 and 5. So I'm going to start by drawing my number line. And I have negative 6 here and 5 here. So I want to know the distance. So I know that from negative 6 to 0, it's going to be 6 units. And I know that from 0 to 5, it's going to be 5 units. So that's a total of 11 units. We can also use finding the difference and then the absolute value. So we start with our end point, which is 5. We subtract it by our beginning point, which is negative 6, and I can use the additive inverse here, and I'll still get 11. Number 3, 5 and negative 15. So again, I'm going to start with the number line. So I have 5 here, and I have negative 15 here. So I know that from negative 15 to 0, there's 15 units, and from 0 to 5, there's 5 units, so that's going to give me a total of 20 units. I can also use the difference and then the absolute value by taking my end point, negative 15, subtracting it by my beginning point, negative 5, and that's going to give me negative 20. Then I'm going to take the absolute value of that, and that's also going to end up with 20. Number 4, here's my number line. Negative 15's here, 7's on the other side. The distance between negative 15 and 0 is going to be 15, and the distance between 0 and 7 is going to be 7. And if I go ahead and I add them up, they're going to give me 22. So there's 22 units in between them. You can also take 7, the ending point, subtract it by the beginning point, which is negative 15. You use the additive inverse, so change these both to plus sign or positive, and you're still going to end up with positive 22. Here we have some word problems. Number 5. The top of an iceberg is 15 feet above sea level. The bottom of the iceberg is 105 feet below sea level. What is the distance from the top to the bottom of the iceberg? So usually with word problems it helps to draw a picture. So here's my iceberg. It's kind of diamond shaped. Okay, and if for those of you that don't know, an iceberg is usually like a big old chunk of piece of ice on top. Then there's the water, and what not a lot of people know is that there is a whole bunch of ice that are still there. This is also one of the things that sank the Titanic, one of the biggest ships back in the day, but anyway. Okay, so going back to our problem, the top of an iceberg is 15 feet above sea level. So you can kind of think of the sea level as 0. So if you want to kind of think of this as like a number line. And sea level is right at 0. So the top of this iceberg right over here, that's 15 feet. And the bottom of the iceberg is 105 feet below sea level. So you can think of the bottom right here as 105 on a number line. What is the distance from the top to the bottom of the iceberg? Okay, so there's 2 ways to do this. The first way is to figure out what is the distance between 0 to 15. So we know that the distance between 0 to 15, that's going to be 15. And we know the distance between 0 to negative 105, let me go ahead and put a negative there. Negative 105 is 105 units as well. So now to find the distance, all you got to do is take these two and add them. So 105 plus 15. So it's 120 feet as the distance. Now we can also use the difference of the two and then finding the absolute value of that. So we're going to start with our ending point, which is negative 105. And we're going to subtract it by our starting point, which is 15. And we're going to go ahead and add those together. Now the additive inverse, I'm starting at negative 105 and I'm going even more left into the negatives 15 units. So I'm going to end up with negative 120. Then I'm going to take the absolute value of that, and my answer is going to be 120 as well. So either way, you're going to get 120. Number 6, a gopher begins digging at 7 inches below ground level and stops digging at 16 inches below ground level. How far did the gopher dig? So again, drawing a picture usually helps out. So 7 inches below. So I know that my number line is going to be like this, and 0 is going to be my ground. Okay, so you can even put some grass on it, some blue grass. Okay, so that's 0, so it begins digging at 7 inches below ground. So 7 inches is negative 7, and it stops digging at 16 inches, so we're at negative 16. So I basically want to know what's the distance between these two. Okay, so from 16 to 17, an easy way to do it would be to take 16 minus 17. And if I subtract 16 minus 7, I'll get 9. So there's 9 inches in between negative 7 and negative 16. Another way to do it is you start with the end point, which is negative 16. You subtract it by the starting point, which is minus 7. So you have negative 16 minus negative 7. Because of additive inverse, we change this both to plus, and you're going to go ahead and subtract it, so it'd be negative 9. And once you get negative 9, you find the absolute value, and there's the distance. Alright, and finally we made it to the end of the video for our very cool math problem. Why did the right angle go to the beach? Now, if you don't know what a right angle is, or a right triangle is, it's basically a triangle that looks like that. And the answer to this is because it was 90 degrees and it was too darn hot. Ha ha ha.